In this video, we'll briefly go through how a good graph looks like. Once the data representation table is done, you proceed to the graph. And using math to help you, we always say that plot y against x. So you'll know that your y will be your vertical axis followed by your x on the horizontal axis. So with that in mind, when the instruction tells you that it wants height against time, make sure that the height is the vertical axis while the time is the horizontal axis. It will be good to include the title of the graph. So in this case, graph of height against time. So you just write it at the top here. Next, you have to look at your data in the table. So the graph may not actually necessarily start from 0. So for this case, all right, in order to fit the graph into the graph paper and it occupy more than half the page, so I can draw a diagonal line here if you want. So the 0 will be for the vertical axis, while the 10, instead of 0, it starts from 10 for the horizontal axis. Next, we need to choose an appropriate scale that can fit the range of your data and is easy to read. So like this is considered a one big square over here. So you must make sure that your big square should be a value that is divisible by 1, 2, or 5, an interval of 1, 2, or 5. So in this case here, you have an interval of 5, or in this case 0.5, and then 1.0, 1.5. This will make the plotting the points easier because each small square is very easy to identify. Do not use odd scale, like for example 0, 3, 6, 9, because you'll find that it's very tedious to locate your points. Another important thing is to make sure that the plotted point should occupy at least half of the graph paper. Now what it means is before you draw anything, you have to look at the first and the last point of your data, and if the first and last point occupy more than half of the horizontal axis, and likewise first and last point occupies more than half of the vertical axis, the scale is correct, so you can proceed to drawing the axis, okay, with a bold line. So some students always, lazy to draw, they didn't draw the vertical and the horizontal axis, so make sure you do that. Next, you must label the axis. So it's very important you basically follow the header. So this is height slash followed by the units, in this case cm, and the horizontal axis is time t slash followed by s. Alright, without the units there, marks will be deducted also. And for the scale, make sure that the values are marked at regular intervals on the axis. Usually at every big square will do. So usually we will mark according to ASPL. So by having done your axis properly and labeled properly with the interval labeled on the axis properly, you have this 2-point axis and for the scale. Next, based on your data, you will plot the points with cross or dot. Now usually we advise you to use cross because it's easier to see, because when you put the dot and if the line passes through, the teacher might miss out on the points. Once the points are done, alright, the next thing is to draw the best fit line or curve. So depends on the question. Sometimes the instruction will tell you. If not, okay, you will just use a thin pencil and a ruler to draw the best fit line here. Now if you're unsure about how to draw a best fit line or curve, you can refer to another video where I'll show you various examples how to plot the best fit. One thing to take note is the line is usually drawn within the range. So you must draw this the first point and the last point. You try to draw the line, best fit line, within the range, unless you're required to extrapolate. That means you have to extend your line, then you do that. For example, they ask you what is when time equals to 80, so what will be the height? So you can extrapolate and then extrapolate the graph, and then you can look for the value. So once all these are done, you will get all the points because all the crosses are there and they are correct, and then the best fit line or best fit curve. So the graph itself, you will be usually awarded 4 marks. Next, usually if the graph is a straight line, they may ask you to find the gradient. And a convenient choice for coordinate is one which lies exactly on the corner of a small square. So you look at your graph here, and then you must choose 2 new points for the gradient, okay, ideally. and you choose, for example, in this case, you're choosing this, and you have to write the coordinates here, and likewise another point is here. So you write the coordinate. Now, to help the marker check whether your 2 points, the coordinates are correct and are they on the line, okay, you can help them by drawing the dotted triangle over here, because then they can pinpoint what is the point that you use and they check against your coordinates here. So you must write the coordinates and the dotted triangle. This presentation on the graph is important for your gradient. So once this part is done, you will, just like your math, you can show the working for how do you find the gradient y2 minus y1 over x2 minus x1. But that working should not be done on the graph paper here. Okay, do it in the space provided for you. Now, sometimes there might be a case where one of the point, let's say this point here, is here, and it's quite out of the norm compared to the rest of the points. So when that happens, this point is considered a anomalous data, and what you can do is, if you do not have time to repeat the experiment again, and you want to proceed with the experiment and draw the graph because you don't have time, then you can just circle out and you can ignore that point. And lastly, if there are cases where they ask you, for example, when time equals to 55, so what's the value of the height? So if that's the case, you have to draw the dotted line, and then when it touches your curve or the line, okay, then you have to draw the dotted line against the vertical axis to show the marker how you get the value for the height when the time is 55. So all these presentation on the graph, they are important. One last thing I've forgotten to mention is the 2 new points for the gradient on the line has to be far apart. A general rule of thumb is, if this is the first point and this is the last point, and you halve that length, so your 2 points must be slightly longer than that length, half that length. So in general, if possible, just choose 2 points that are far away and it's easy to read. Alright? Lastly, if you are asked to draw a conclusion for the graph that you have just plotted, okay, just be mindful. So in this case, you can see that the line is a straight line with constant gradient, but it does not pass through origin. If that's the case, you can only conclude that the D, that's the vertical axis here, in this case is distant, the D is increases linearly with T. Alright, and if the graph is a straight line with constant gradient and it passes through origin, then you can conclude D is directly proportional to T. And lastly here, now for this case is non-uniform, of course, so what you can say is as T increases, the D increases non-linearly. That means it's a curve. So that means to say, if the graph is this way, this is also true, and in general, describing this way is sufficient. But of course, if you want to be more precise, you can say that for this one, as T increases, your D increases at a increasing rate. You can write it this way. Alright, and likewise for this, as T increases by equal interval, okay, equal amount, your D will increase. D is still increasing, but at a decreasing rate. Okay, if you want to be more specific, you can do that. You might be wondering, what if the DT graph, okay, is a constant negative gradient? So if that's the case, as T increases, your D decreases linearly because it's a straight line. So having said that, for this case, you want to be more consistent, you can also say that as T increases, your D increases linearly. So it's easier to remember this way. And how about if the graph is a negative gradient but is curved this way? Following this format, I can just say that as T increases, D decreases non-linearly. Alright, but this will be sufficient. So, but if you want to make it more specific, you can say that as T increases, D decreases at a decreasing rate. Alright, so I hope you get the idea. So with this video, I hope you roughly know how to plot the graph in order not to lose any points, and how in general you can conclude the graph.